So today we have Unit 4, Day 4, Notes, and Learning Target 6, which is trig functions of angles. So as a nice little warm-up, let's apply the unit circle to the 6 trig functions. So first off, let's draw out our quadrants. Draw out your unit circle. Let's put the signs in. So in the first quadrant, cosine and sine are both positive. Second quadrant, cosine is negative, sine is positive. Third quadrant, they're both negative. Fourth quadrant, positive cosine, negative sine. And then let's draw out a triangle, because remember, unit circle is made up of triangles. And let's label this the x for the cosine, right? X-axis, y is the height for the sine, and the hypotenuse of any triangle we draw in here is the radius of the unit circle, which we all know the radius of the unit circle, because it's called a unit, is 1. So there's 6 trig functions. The ones that we probably already know is cosine, sine, and tangent. And if you just write cosine and tan, that means absolutely nothing. That is improper notation. You are taking the angle measure of whatever I give you, and what is the cosine of it, okay? So you need to have the angle measure. If you're looking for that, right, then we put that theta in. So with respect to that triangle I drew in, cosine, remember, so COTOA is adjacent over hypotenuse, so x over 1. Sine is opposite over hypotenuse. And then tangent is OA, so opposite over adjacent. So these 3 are probably more famous, or like you know them a little bit more from last year. With cosine comes secant of theta. So we pronounce it secant. And then we have cosecant of theta. Cosecant. And then we have cotangent of theta. Cotangent. These are pretty much the reciprocals of the first 3. So all you have to remember is to flip. So 1 over y and x over y. Now, we'll have a lot of sayings for this unit. My saying to remember the reciprocal ones is that every pilot has a co-pilot. What does that mean? So every pilot, meaning anything, one of the 6 trig functions that doesn't start with a C. So every pilot has a co-pilot. Every pilot has a co-pilot. Starts with, co-pilot starts with a C, and every pilot doesn't start with a C. Every pilot has a co-pilot. This kind of helps out students remember which one goes with which, okay? Alright, so yes, you will have to know these 6 trig functions. So let's do some practice with these and let's evaluate. So example 1. Evaluate options. And then let's keep answers exact. Alright, so that means we want to keep our square roots in our answers, our pi's, everything, okay? So let's start off kind of nice. Let's go A, sine of 30 degrees. So sine of 30, at this point, you should draw in a unit circle. So pause me, draw in a unit circle, and you're only supposed to be drawing in the first quadrant. You will be using reference angles to figure out everything that is outside of the first quadrant. Remember, reference angles comes from day 3 notes. Alright, so pause me now, draw it out, and then unpause me. Alright, so after now you unpause me, you should have written down that the sine of 30 degrees is 1/2. B, cosine of 5 pi over 6. Okay, so if I briefly, really quickly, I estimate where 5 pi over 6 is. I am about here. I know the signs are in here are negative and positive for cosine and sine. So I know my final answer is going to start negative because of this. Then I realize, what is my reference angle? My reference angle is pi over 6. That's how much short I am to get to pi. So pi over 6 for cosine is square root of 3 over 2. And that's my final answer. Alright, letter C. The tangent of 4 pi over 3. I'm going to do a really quick sketch. Tangent 4 pi over 3 is in here. Because if this is pi, I am off by pi thirds. I'm a little extra. I know the signs in here are both negative, negative, which will make my final answer positive, because a negative over a negative. And my reference angle is pi thirds. That's how much extra I went. So pi thirds, when I think of pi thirds, and I think of SOHCAHTOA, opposite over adjacent. So the sine is negative root 3 over 2 over negative 1/2. And if I multiply these out, multiply by the bottom reciprocal, get a positive root 3. Great. And then that leaves us with letter D. Cosecant of 3 pi over 4. So every pilot goes with a copilot. So cosecant, looking back up here, goes with sine. So again, same thing. Draw a rough sketch. 3 pi over 4 goes in here. I'm off by pi over 4. That's my reference angle. I know the signs in here are negative, positive. Cosecant, you just told me, goes with sine. So it's 1 over sine, right? So I get 1 over pi over 4. Sine of pi over 4 is root 2 over 2. Make sure you rationalize this, right? So first let's just multiply by the reciprocal. Multiply everything by square root of 2 over square root of 2. Good. Square root of 2. So let's do some definitions then. Definition of trig functions. Okay, so trig functions are periodic. What does that mean? They repeat. So therefore, coterminal angles have the same value for these 6 trig functions. So example 2. Let's evaluate A. Cosine of 13 pi over 6. Again, if you do a rough sketch, 13 pi over 6, well, if here's pi, here's 2 pi, it's one full rotation and a little over, and the little over part is pi over 6. So pi over 6 is that reference. So cosine of pi over 6 is root 3 over 2. B. Cotangent of negative 5 pi over 4. So negative 5 pi over 4. Let's draw a sketch. Here's pi, here's 2 pi. Negative 5 pi over 4. I'm going clockwise. This would be pi and a little bit over. That is equivalent to 3 pi over 4. Look back at the beginning of the notes when we wrote down the 6 trig functions and cotangent, and figure out who does cotangent go with, and pause me here. Alright, you should have unpaused me, and you should have realized that cotangent goes with tangent. So now I have cosine of theta over sine of theta. My reference angle of 3 pi over 4 is pi over 4. So cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. But technically, we are hanging out in quadrant 2. And in quadrant 2, our signs are negative, positive. So a negative for the cosine. Clean this guy up. You should get a negative 1. Alright. Example 3. Find the exact value of these 6 trig functions at theta equaling 5 pi thirds. Alright, so let's draw a sketch. 5 pi over 3. Again, I label my pi and my 2 pi. 5 pi over 3 is closest to the 2 pi. So I would be somewhere here. And now, how much am I missing to get to 2 pi? I'm missing a pi thirds. So that means my reference angle is pi thirds. And in this quadrant, my signs are positive for cosine, negative for sine. Okay. So let's start off with the first three that we're most comfortable with. So cosine of the actual angle, so 5 pi over 3, make sure you give me that. Then I have sine, 5 pi over 3, then I have tangent. Alright, so let's actually use the reference angle of pi thirds. What is the cosine and sine of pi thirds? 1/2 root 3 over 2. So we're going to use those guys and these signs to evaluate. Alright, so cosine 5 pi over 3, 1/2. Sine of 5 pi over 3, negative root 3 over 2. Tangent, sine over cosine, negative root 3 over 2 over 1/2. Clean it up, you should get negative root 3. Alright, so cosine goes with secant, 5 pi over 3. Sine goes with cosecant, 5 pi over 3. And cotangent of 5 pi over 3. All we have to do here is flip. So 1/2 becomes a 2. Flip negative square root of 3 over 2, and then you will have to rationalize. And you should be getting this. And lastly, cotangent, negative square root of 3 over 3. Alright, this would be a good spot to pause me, figure out if you have any questions, where did any of the answers come from, before moving on to example 4. Example 4, we need to find the exact value of these 6 trig function given the point -7 over 25, 24 over 25. So given the point, that guy that lies on the terminal side. Alright. So let's do a rough sketch out. And let's think, where would this point be? I have a negative cosine and a positive sine. Well, I believe that matches quadrant 2. So drawing this guy in, I know that my point is -7/25 and 24/25. So let's write out our 6 trig functions. Cosine, sine of theta, tangent of theta, and then I would also write out the ones that they go with. So we have a secant of theta, cosecant of theta, and a cotangent of theta. So cosine, well, isn't cosine just the point? So cosine is -7/25. 7/25. Sine, take the sine from the coordinate. So 24/25. Tangent will end up being what? -4/7. And remember the reciprocals, flipping these guys. I'll have a -25/7, a +25/24, and a -7/24. Again, this would be a good spot to pause before we hit the last question. All right, example 5. Find the exact value of these 6 trig functions in quadrant 3 given tangent of theta is equal to square root of 5/2. Okay, so the above example, I gave you actual coordinate, and from that you should know which quadrant it's in. This one, I'm telling you which quadrant it's in. So I'm in quadrant 3. Great. So let's draw an angle in quadrant 3. Tangent, referencing back, is y/x. So I need to figure out what are the sides of this triangle, knowing tangent of theta is square root of 5/2. So let's think. Cosine and sine are both negative in quadrant 3. Tangent, so sine over cosine. Well, sine is the y value. So there I have that, right? And of course, the angle's coming out from the center. And then I have a 2 for the x. But what has to be true? They both have to be negative because they are both in quadrant 3. So I need this last side of my triangle. Well, isn't this a right triangle? And how do we find a missing side length of a right triangle? Pythagorean theorem. So you should do Pythagorean theorem, and you will get x is equal to a positive or negative 3. Does that make sense? Can the radius ever be negative in a circle? No. So we only take the positive. Alright, so let's write out our 6 trig functions. Let's start off with cosine. Cosine, adjacent over hypotenuse. Sine, opposite over hypotenuse. Tangent should be the one that was given, right? And it does match up. I would have a negative square root of 5 over negative 2. Positive then, negative over negative. And then secant, let's flip, negative 3/2. Flip this one, you will have to rationalize still. In your notes, you should probably show that step out, and you should get to this. Same thing with the last one. If you flip, you should be rationalizing, and you should get this answer. Alright. make sure you understand all the questions. Email me if you have any questions about it to set up an appointment to meet up with me, or if it's just something really quick, then just email me. You guys always know you're welcome to do that. These will also be posted as the hard copy under modules, so please, please, please advocate for yourself. Do what you gotta do. Try those homework problems. All right, see you guys tomorrow.